angle of depression what are we going to do with you? All right, so we got eagle on a cliff looking down at a mouse. The angle of depression is 28 degrees. The mouse is 253 feet from the eagle. Find the height of the cliff. All right, so you understand my hieroglyphics there?
Yeah.
So here's the eagle, he's looking down, the mouse down there. The angle of depression is 28 degrees. The distance from the eagle to the mouse is 253. We want to find the height of the cliff. Okay? Well, so what does our picture look like? Our picture looks like this, with the eagle here and the mouse here. Would you agree with that? Where does the angle go? Always, right? Always. Very technically, the angle goes right here, because that would be his angle of depression. But that angle will always match this one, so we're just always going to put it right there. Where does the 253 go? Hypotenuse. Eagle to mouse, not mouse to cliff. Mouse to cliff would be here. Mouse to eagle is here. Find the height of the cliff. It's going to be a sine problem. So we're going to say sine 28 equals x over 253. And then x equals 253 sine 28.
That's right.
And then if we have a calculator, we just rip it out and type it in, right? If we don't have a calculator, we have to stop here. That is our equation.
That'd be our answer.
That'd be your answer. That's the equation right there. Okay? All right. Negative 30 degrees. Find the smallest positive coterminal angle. What do we do to find the smallest positive?
Subtract 30.
360. I add 360. So 330 degrees would be the smallest positive coterminal. How do we find coterminal angles? We either add 360 or we subtract 360.
So when you subtract 360, that would be
No. Magnitude wise, it's the smallest. I know what you're saying on the number line, but in terms of an angle, if I draw negative 60, that is smaller than negative 150. We're talking about the size of the angle, not its direction. All right, and then how about 7 pi over 12? What is the smallest negative?
I'd add 2 pi.
Coterminal
Or
angle?
you have to subtract 2 pi.
Subtract 2 pi, so 7 pi over 12 minus 2 pi.
So 24
So
over
we
12.
get a common denominator. So it's 7 minus 24, which would be negative 17 pi over 12. Finding coterminal angles is the same no matter what. You either add a revolution or subtract a revolution. If you're in degrees, it's 360. If you're in radians, it's 2 pi, right? All right, one more on this paper. Okay, so somebody tells me that the tangent of the angle is √3, and the angle is between 0 and 2 pi, and we want to know what the angle is. So we're working backwards. We want to know what is the angle whose tangent would be √3 over 1. Okay? So think about that. What would the triangle look like if the tangent was root 3 over 1. Isn't that tangent root 3?
3.
So how big would that angle be right there? That's a 60? But I'm in radians. This is your clue, you're in radians. So 60 is what fraction?
Pi over 3.
It's pi over 3. It's pi over 3 radians. So one answer would be pi over 3. Now, why did I say one answer? Because there's another place. Quadrant where? Why is quadrant 3? Because they're both negative. So when you do your tangent, you end up positive. This is still a 60. Right? But what about radians? Well, this is pi over 3. So isn't this a pi? So it's a pi and a third? 4 pi over 3. Right? Okay. All right, now I found another sheet. We may or may not get through the whole thing. And the first one, I think we've already done. This is an actual quiz I gave at some point. Way back in the day. When I was an administrator, actually. I could tell because I only had one class those years. And it was period 5.
Period 5?
Yeah, period 5 was the best because they were my onlys.
Why'd you stop being an administrator?
Let's just say.
Quit.
Did everybody get one? Okay. Alright, so number 1 we already did. We did that on a different paper, so we're gonna skip number 1 so we have time to get the whole thing done.
I have a question.
What?
So when you're like writing like a, say like you're writing a sign, and you start from the negative, and like it's the period's too high, would you add like say you're like you start negative pi over 4, but your period's too high, do you add the negative pi over 4 like you're still adding like it's an actual negative?
Yeah, because it is an actual negative.
So it'd be
3 pi over 4. If you added pi, if you added 2 pi, it'd be 7 pi over 4. Yep. Alright, here we go. This looks like something we've already done too, but we'll do it again because it's worth a lot of points. And just for fun, there we go. So just stick a little +1 on that. Alright, so we're going to graph a sine curve. And I'm going to have to lift the whole thing up 1 unit. Would you agree with that? So this is going to become my new axis right here. Now the amplitude is 2, positive 2. Normally I would go then negative 2 to 2, but now it's going to be negative 1, and I'm going to go ahead and just make another little dash line down here, and 3. Because that's going to help me keep my curve oscillating in there. You don't have to do that. Now what else do I know? Oh, I know I start valley first, and I start at pi over 4. So I'm going to make this pi over 4. This is where I'm going to start, right here. And I'm going to do my valley, and then my hill. So everybody take a look at that and see if what's happening is making sense so far. So now, I gotta find my period. What's my period? Well, it's supposed to be 2 pi, but I'm dividing by a half, so it's 4 pi.
That means your frequency is 1.
And so my frequency frequency would be 1 over 4 pi. Now, where am I gonna end? Take your starting point and add 4 to it.
17 pi was
So 1/4 plus 4 is 17/4. That's exactly right. 17/4. Right here in the middle, which I'm not very good at speaking, but there I am in the middle. That would be 1 and 17 is 18. So that's 9. And here's the bottom, and here's the top. 1 and 9,
5 pi and a half.
5 pi over 4. 13 pi over 4. Good. I'm going to add one more little thing in there while we're here. What if the problem had been exactly the same thing, but it was a cosecant? Now, would any of this work be wasted? No, no. Because if it's a cosecant, I'm going to do that exact thing. And then you remember what we do? We drop in an asymptote wherever we cross our axis, right? So we're going to draw in an asymptote at pi over 4, 9 pi over 4. These are now this is my axis right here now. So that's where my asymptotes are going. And then this one comes down, and this one goes up. That marker is trash.
And then only time you have like partial gravity
And
y.
the cosine. You start with the cosine.
How many markers do you use?
Now, let's talk about this for a second. Let's start with the red curve, or the black curve. Start with the black curve. Period is 4 pi. Frequency is 1 over 4 pi. Amplitude is 2. Phase shift is pi over 4. Vertical shift is 1. Okay. Now, go to the blue curve. The green, whatever this is. Go to that. Amplitude is none. None. No amplitude for anything other than a sine or a cosine. Okay? Period is still 4 pi, and everything else is the same. Frequency 1 over 4 pi, vertical shift 1, phase shift pi over 4. Okay? All right. Number 3 on this quiz. We already did one like this. Let's see if you remember. We're finding everything. We know what? We know the cosine is 5/13, which means the secant is 13/5. You know you're going to need a picture, and the problem tells you where to draw the picture. Where are we going to draw the picture?
Quadrant.
We're going to draw the picture in quadrant 4. How did you know it's in 4?
Between 270.
Between 270 and 360. And the cosine is 5/13. How does that look, okay?
The dagger is there.
Yep.
It's 13 squared.
169 minus 25 144.
Negative 12?
Yeah.
Negative 12? Remember, that's C. A squared, B squared, C squared. All right, so sine is negative 12/13. Cosecant's negative 13/12. tangent is negative 12/5, negative 5/12.
What's that?
Ron, you okay? Okay. What happens if you screw up your Pythagorean theorem? Bad news, right? That 12 showed up in 4 answers, so make sure you do your Pythagorean theorem correctly. All right, sine, 4 pi over 3.
Three.
240.
240. So using, I'm gonna use this same graph over here so I don't have to redraw it. Won't 240 be right here?
Yeah.
Perpendicular straight up?
You're basically 60.
This is the key, right here.
60.
That's not part of this problem, right? This is my angle right here, and that is 60. Would you agree with me? Which is root 3, 1, and 2. Those ratios are on your cheat sheet.
Sine equals
Right.
3.
These are both negative, so be sure you're marking them. You want sine, which is opposite over hypotenuse. Negative root 3 over.
Change that to
Now, boys and girls, look at problem 5 and 6. They are different. Okay? Now, problem 6 is arc length. Arc length is radius times radians. I do not need, I can, you can always change. You don't need to change 70 to radians here because you're not doing that formula, right? We're not doing arc length. Right? What's the area of the whole circle? The whole circle is 25 pi, pi over square. I am not interested in the whole circle. I am interested in a fraction of the circle. 70 over 360. That's the fraction I'm interested in. 73/60ths, which is 7/36 of the whole circle. So it's just like taking half of it. Only I don't want half of it, I want 7/36 of it. So that would be 175 pi over 36. Now, that's different than
arc
arc length. Because arc length requires me, at least if I do this formula, it requires me to have the radian measure of the angle. I know my radius is 4. I need to find the radian measure of the angle. Remember how to do that? Pi over 180 equals x over 100. So 180x equals 100 pi. And x equals 100 pi over 180, which is 5 pi over 9. Are you guys with me here? Okay, so multiplying those two together, my answer is 20 pi over 9 inches, because this was inches. Okay? Alright, so now we have 9 more minutes, Jake.
What?
What do we still need to review? Between all these old things I've given you, we've hit a lot of different things. What do I still need
I think I need some more sketch.
to go over? What do you need?
Some more sketch work.
Like sketching what?
Graphs. Any kind of graph.
Sketching a secant.
A secant. So let's do 1/2 secant 3x minus pi over 2 plus pi over 4 over that. Okay? Two things are going to happen in my mind right off the bat. One of them is I'm going to think of that not as a secant but as a cosine. Because I know how to graph cosines. So I'm going to graph a cosine. The second thing I need to take care of
Yeah,
is
pull it out.
that. So 1/2 secant 3 x plus pi over 12. Very, very good. Very good. 3 times the 12 is beautiful. And I said I was going to think about it as a cosine. Make that cosine. All right, so now what is that going to look like?
Wait, why'd you?
I'm going to graph a cosine. So it starts at negative pi over 12, has an amplitude of 1/2, and it's a cosine. So cosines start up here at the top of their hill, right? And then they come down and up. They end right where they started. So if it started at the top of the hill, it's going to end at the top of the hill. Speaking of ending, where's it going to end? Well, it's going to end 1 period from where it started. So what's its period?
2 pi over
2 pi over 3. So to get my ending point, I'm going to take negative 1/12 and add 2/3. I'm leaving the pi's out to make it really
7 pi over
easier.
4.
So negative 1/12 and 8/12 is 7/12. So this is 7 pi over 12.
Which means that one.
So the one right in the middle, which would be the bottom of the valley, negative 1 and 7 makes 6, and half of 6 is 3. Negative 1 and 3 is 2, and half of 2 is 1. 7, this is going to be 5. All right, Hayden, you keep up with all that? Now, I'm not done though, because remember, the original problem
Draw your ass.
was a secant. So I need to put in my asymptotes where I cross the axis, the x-axis, and then I start flipping. So this one is a half and upwards. This is a downwards. And this is the other half of the upwards. If you have to list, period, amplitude, all that stuff, remember a secant will have no amplitude. But it will have everything else the same. So it's period, frequency, all that stuff will be the same.
Do we have to put the plus or the positive for the phase shift and vertical shifts?
No, if they are positive, just putting the numbers fine. If they're negative, you'll have to include the negative down. So negative or down. So this phase shift would be negative pi over 12. Dana, are you listening to me? The phase shift would be negative pi over 12.
Yeah. Okay. Yeah. So you don't base it off of the problem. What? Because like you don't
That's
just
exactly
like.
what you do.
Yeah. No, I'm saying like there it says x plus pi over 12, but plus is it's the opposite of
Yes,
what. So you don't
yes.
want us to write that. You want us to
No,
write
the
that.
phase shift is where you start. This is where I started. All right, I have time for another question. Who else
Dana, you were
has
wrong.
something that you're you're concerned about. Remember, tomorrow will not be all period. Alright, because it's not a whole 4-page, 5-page test.
I have a question for 4.5, but it's in the notes.
I don't care.
Like, 10x equals 1.75.
That would have to be a calculator problem. That says find the angle whose tangent is 1.75. So, I guess I'll do it in radians. I don't know how I'm supposed to do it, so I'll do it in radians. So second tangent, 1.75 is 1.05. So the angle is 1.05. So one of my answers is 1.05. But just like before, I could also be down here. Because isn't the tangent also a positive number in quadrant 3? So I would take 1.05 and add pi to it and get 4.19. So the two answers to the problem would be 1.05 and 4.19 in radians. Okay, that's exactly like the one we did by hand, except this wasn't 1.05, it was root 3, which is one of my special numbers on my triangle, so I could do that with my hand. This one I need a calculator for.
How did you get to 1.05?
Type it on my calculator. Second tangent, 1.75 in radians. Okay, all right, so that's that. Tomorrow is our quizzy poo.
You clear all the debts?
I didn't. Manny Egan came in and paid it all.
Oh, what a
He paid
fun.
everybody.
$5. What a guy.
He does more than $5. He did it in 2 different,
Did what?
he handed me some money. I can't remember how much it was the first time, and said, how many will this pay for? So I just erased it. I didn't care. He said no, so I just started erasing. And there were only like 4 left. So he handed me a couple more bucks and said,
Wow, what a guy. What a
He's
stand-up
a
guy.
servant of God. Like,
He's a servant. Yeah, I respect him.